Assalamu alaikum students. I Dr. Bilal Makpool teaching you Java. Today's topic is iteration statements in Java. We will see first of the thing is we will see what are iteration statement, why we need this, and what are the different types of iteration statements in Java and how we can use those iteration statements. Let us see first what are iteration statements. Iteration statements are those statements which helps us executing a set of instruction again and again unless the condition specified in the iterative statement will become false. That means the iterative statements are executing in sort of a loop. That's why we call sometimes or usually we call those as loops as well. The another name of iterative statements are loops, or we can say the heading should have been loops in Java. What we can say loops are those statements which helps us executing a set of instructions inside the block of the loop again and again unless the condition specified in the loop will become false. The different types of loops which are available in Java are for, while, and do while. That means these are the three basic iterative or loop statements available in Java. We're going to take one by one. First for loop, then while loop, then do while loop, and we will see the general syntax of loops, each and every category. Then after we will have some examples, real-time examples or real-time execution of those statements. Let us see first for loop. For loop is one of the category of the loops available within the Java, and its general syntax is for initialization, initialization, semicolon, condition, semicolon, increment or decrement, and then it will be a block of statements, then after it will have closing. This is the general syntax of our for loop. That means a for loop will have three sections. First, the initialization section. Second one is the conditional section. Third one will be the increment or decrement section. So let us go to the execution part, how we can execute this. So what we are going to take int something now. We'll take a problem which will add the sum of first n numbers. So until this program, we were using the hard-coded input. But from this program onwards, we will use the scanner class. What are scanner classes first? Scanner classes are used to take the input, or one of the utility of one of the usage of scanner class is to take or to grab or to scan the input from the console. See, for example, we are going to use like this. Scanner in will be equivalent to new scanner system dot in. So it's one of the uh, particular class available in the util package of Java, and it provides us the feasibility that it will take uh, the input from the console. So we need to take the number value of this number num. We will do like this: system dot out, enter the value for num. What? After that we will do like this: num will be equivalent to in dot next int. So because we are dealing with the integer, as you can see, there are many methods available uh, for this scanner class. There's a hash code, there is next byte, there is short, there is integer, there is equal, there is find in line. There are many methods available with this, but there's next, there are many methods, but today we are going to use next int. Next int means take the integer from the console, and after that what we are going to use, we are going to use system dot out dot println the summation of first n number or summation of numbers from 0 to 0 to num. कितना है हमारे पास? अभी हमने calculate, we have not yet calculated it. How to calculate it? That means we need to have for loop for that. For int I equivalent to 0 or I equivalent to 1, let's start with I less than or equivalent to num and I plus plus. After this, what we are going to do, we are going to hold a particular summation in a variable. So let us demonstrate here. Sum will be equivalent to 0. So what we are going to do, we are going to use like this: sum plus equivalent will be I, or in other terms it can be demonstrated as sum will be equivalent to sum plus I. So these two states are one and the same thing. And after, when a loop will get executed, we will write down like this: system dot out dot print sum, because everything will be now stored in sum. Say when we are going to run this particular program, it will show me enter the value for n. Enter the value for n, for example 5. The summation of number from 0 to 5 is 50. Say 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Obviously it is showing, but how this for loop is executing? Let us demonstrate it further. Say at the first time the value of I will be equivalent to 1. The condition is here, the value of num is 5. So the condition will be equivalent to 1 less than 5. Condition will be equivalent to true, because 1 is obviously less than 5. Then the statements available within this gets executed. The statements are sum will be equivalent to sum plus I. That means sum is at the initial level, sum is equivalent to 0 at initial level. So हम क्या कर रहे हैं? Sum will be equivalent to sum plus I. What does that mean? This means sum will be equivalent to sum पहली बार 0 था plus I पहली बार 1 है, so it will be equivalent to sum will be equivalent to 1. Clear? उसके बाद after this, if we have any particular statement that will get executed, but we don't have within the loop, so it will jump to the increment part. That means increment part will be there. I will become the previous value, which was 1 plus 1, it will become 2. Now I is exactly 2. Now again 2 less than 5 condition is again true. After this, now the summation will have a value as previous one. Is it? हम फिर से कर रहे हैं. Sum will be equivalent to sum plus I. Sum plus I जब कर रहे हैं हम, it will be equivalent to sum will be equivalent to sum का previous value क्या था? 1 था. Plus I का अब current value क्या है? I का current value 2 है. So we are going to use 2. So it will become 3. Summation is equivalent to 3. Now current value of I, that means 2 plus 1, because increment is, we are going to take increment, which is equivalent to 3. Now current value of I will become 3. Is it? Now 3 less than 5. Condition is again true because 3 is less than 5. Now sum was equivalent to, previous sum is equivalent to 3. Again sum will be equivalent to previous sum, which is equivalent to 3, plus current value of I, it is 3, which is equivalent to 6. Now increment part will be 3 current value of I plus 1, which is equivalent to 4. Again the current value of I will become 4. 4 less than 5, condition is true. Now previous value of sum was equivalent to 6. Now where sum will be equivalent to previous value of sum, that means 6, plus current value of I, 4, which is equivalent to 10. Now I will get incremented. I will become 4 plus 1, which is equivalent to 5. Here in this program, as you can see, we have denoted it as less than or equivalent. So we will write down here as well. Less than or equivalent to, same. Less than or equivalent to, less than or equivalent to, less than or equivalent to, less than or equivalent. Again, when current value of I will become 5, so 5 less than or equivalent to 5, condition is, because there exists less than or equivalent, either it should be less than or it should be equivalent. So 5 is equivalent to 5, condition is again true. Now sum was equivalent to 10. Now new value of sum will be equivalent to past value, that was 10, plus the current value of I, that is 5, which is equivalent to 15. And after that I will become 5 plus 1, which is equivalent to 6. Is it? Now 6, the current value of I will now become 6, and after 6 less than or equivalent to 5, condition here becomes false. When condition becomes false, it comes out of the loop, and when it comes out of the loop, that means this particular control will be here, and this, after that we have a one statement, printf system.println sum. That means we are printing the sum. That's how the loops execute. Students, before going for another example, that we are going to see how to demonstrate the for loops in more complex form, we have to get an idea, or we have to get an solution how an operator, modulus operator, works in our program. Let us demonstrate first the use of modulus operator, and then we are going to see how the modulus operators can be used in a loop to demonstrate the concept of how we are going to have a program which will check whether a number is prime or not. In the previous example, we have seen uh, how to take summation of first n numbers. Let us take few more examples. Let's take an example where we can check whether a number is uh, divided by 2, or we can say it is even or odd. So we must use like this: int num, again scanner, scanner class, scanner in will be equivalent to new scanner system dot. So we are going to use system dot out dot println, enter the number for, yeah, enter the number, and after that we are going to hold that value into num. So it will be in dot next int. So we take for up to this we have taken the value from the console into the integer num, and after that what we need to check, we need to check whether a number is divided by 2 or not. So for example, if num percent 2 equivalent to 0, we will say that system.out.println divided by 2, or we can say it's an even number, else system.out.println not divided by 2. So if we will run this particular program, we will enter, say for example, 9. It will show me not divided by 2. Exactly, we need to show another program. For this we need this modulus operator. That's why I have seen first, I have taken first the modulus operator that we are going to see in this particular example. Now with this modulus operator we need to check whether a particular number is prime or not. Let's take example of whether a number is prime or not. So in order to do that, we need to have for loops, we need to have a modulus operator, and we need to have few variables. So in order to do the same, we just need like these things like that. Say for example, let's take integer as num, for which we are going to check whether this number is prime or, and from this particular onwards, this example onwards, we are going to use a scanner class. Scanner scanner in is equivalent to new scanner class. Say system dot, and in order to get a number from the console, we are writing like this: num equivalent to in dot next int, and after that we need to demonstrate how we are going to check whether a number is prime or not. A number is prime or not can be defined by its definition. It defines the prime number can be defined as the number which is divisible by 1 and itself. That means we need to keep aside two things: the number itself and the 1. and the factors in between 1 and the number. If the number is divisible by those factors which are in between 1 and the number itself, then it's not a prime number. If it is not divisible by any of the factor, then we can say it's a prime. In order to do that, let us say we are using like this. We have a flag variable equivalent to 0. In order to do the same things, let's say for int I equivalent to 2, because we need to keep aside 1 and the number itself. So we are going to start from the 2. I less than num and I plus plus. What it will give me, it will iterate through me from 2 to the less than number, less 1 by number. That means if number is 7, it will iterate from 2, 3, 4, 5, 6, not 7. It will be less than 7, 2, 3, 4. And it will check on each and every occurrence. It will check whether a number is divisible by 2, whether the number is divisible by 3, divisible by 4, and so on, up to the n minus 1. A similar concept we are going to execute here. We are just checking whether a number is divisible by the occurrence that we are getting here. Is num percent I equivalent to 0? If it is divisible, then check the flag or change the flag equivalent to 1 and break, because as per the definition it tells us that if a number is divisible by any of the in between factors, then that number is not a prime number. So we need not to check again for another. If it is divisible by one factor, we are going to come out of the loop. And similar things I take here. We need to check the flag, whether flag has changed or not. If flag equivalent to 0, if it doesn't change, that means it never comes this block within this block. If block it never comes, that means it's never divisible by that any number, then system dot out dot println number is prime number. However, if it is not, flag is not equivalent to 0, that means somewhere flag has been changed. What does that mean? That means it is divisible by some in between factors. That means else part will get executed. Else system dot out dot print number is not a prime number. So let us execute this particular file first. So it's taking a bit time. So we are taking 7 as a number, prime number. So let us make one change here. We will write down, in order to get a message, we will write down here system.out.print, enter the value for num, and we will again run it so that we will get a message. Say for example 9 is not a prime number. Again we are going to run it. Say 13 is a prime number. So this actually demonstrates how we are going to take for loop in order to iterate the things again and again, because these things have to be iterated. If our number is equivalent to 7, these things have to be iterated at least 5 times. That means 2, 3, 4, 5, 6. That means upon checking upon 2 or checking upon 3, checking upon 4, checking upon 5, and checking. That means 6 iterations should have been there. 6 times this code is being executed, and it is with the help of these loops that we are able to execute the instruction set again and again upon checking some condition, whether that condition is equivalent to true or false. If it is true, it allows it to execute. If it is false, it comes out of that. Hope that you have understood the concept of for loop, very much. Thank you.